The Clean Power Hour is brought to you by Continental Energy Solutions. I'm Tim Montague, your co-host. Today on the Clean Power Hour, we're going to talk Tesla, of course. We're talking about Model Y. I am a proud new owner of a Model Y. And we're going to talk about cell manufacturing. We're going to talk about pollinator-friendly solar product recycling, so many good things. Welcome to the Commercial Solar Guy and my co-host, John Weaver. Welcome to the show, John.
Hey, Timothy, how do you do? Have you folded down the back seats and put a sleeping bag and slept in your Tesla Model Y yet? Because I have. I just want to know.
That's what I was thinking about actually this morning as I was driving over to the supercharger in Champaign. I was wondering, has John actually camped out in his Tesla Model Y yet? And no, I have not, but the thought has crossed my mind. So I'm dying to try it and see. What did you think?
So I did camp out one night for when I went up to the White Mountains, New Hampshire, about 2-3 weeks ago. And it was the exact use case that I wanted. I worked long day and I wanted to climb a hill or mountain, and it's on the northern ridge. So it takes like 4 hours to get there. So driving 4 hours in the morning, driving 4 hours back, that'd be 8-9 hours in the car. And then I'd only have like 7-8 hours to go up and down the mountain. And I'm slow as heck. So I drove up there and slept in the back. I used camp mode. I just put on the vent because the temperature outside was cool, and so I didn't need air conditioning. And I slept fine. The surface it's hard. So, it's like thunk, thunk. So you need to lay down some good mats. And just like sleeping on the ground, your shoulder gets a little sore when you lay on the sides. I'm just short of 6 feet tall. I'm like 5'11" and a half. I will most often lie and say I'm 6 feet tall. But so when I extend catty corner with my head fully on the folded down seat, my feet can't fully extend if I stretch. They're like, my toes are just bent. But if I lay with my head in between the two front seats on the headrest and just kind of have because it's really close to it, the back seats when they're folded down, I can fully extend. If you fold your seats forward, and this is my next idea, just not fold your front seats. If you just zoom them all the way forward and then lean them, you can probably lay a piece of wood that extends the length of those back seats and put, and I'm going to design this, or maybe you just need a piece of flat plywood and just lay it there. You'll add like an extra foot to headroom. And so I think that's what I'm going to do, and just have that piece of wood in the car and slide it up, and boom, now I got a king size bed instead of a double-sized bed is the way I'll be sales pitching it. So slept in it. It was nice. I only lost about 7 miles of range overnight with camp mode on. So, the Model Y, man, Tesla Model Y, pretty neat little toy. I think you need to sleep in it. And if you ever go homeless, well, you got a RV already. So I guess you got a nice vehicle to sleep in. So, it's been on my list just in case.
I have an RV, but I'm not nearly as excited about camping in my RV as I am as excited about camping in my Model Y, just because it's a new toy.
Yes.
Before I forget, it is day 16 of the Solar 500 Challenge. Please subscribe to our channel. You can do that at cesnrg.com/videos. You can find all the Clean Power Hour videos there. Of course, you can find this on YouTube as well. But we're trying to get to 500 subscribers by November 15th. So the clock is ticking. We need 15 subscribers a day, and we have some catching up to do. So please give us a thumbs up, share it with your friends, and let's grow solar for the energy transition. So John, let's get into the news. You visited a ground mount solar site, looks like, and I'm going to share my screen in a second, but I love rooftop solar, but I really love ground mount solar. What was your field trip and what was your experience?
So yesterday I went to visit a 6.5 megawatt site. It's composed of 3 little subsections. They have their own private poles along the line. They were using Longi bifacial, TerraSmart racking, and SunGrow inverters. Nice wiring job. So I liked seeing the solar hardware. But my purpose wasn't actually to see the solar. And this isn't my site. This is a third-party site. My purpose was to speak with Lindsay, who runs Ernst Pollinator Services. Her and Robin run it, but Lindsay I chat with, and Lindsay was on site, and they're doing a pollinator friendly site in Massachusetts, and it must be one of the first ones we're doing under the new SMART program. We're paid like a quarter of a cent per kilowatt hour, maybe half a cent per kilowatt hour, to make our sites pollinator friendly. And I met Ernst and Lindsay and Robin, who owns them, a while back at a show. And so it was just great to learn about Pollinator. And I really wanted to visit the site. Oh, you can actually see in that image, you see Benji, his black top, and you can see Lindsay and her purple top way in the background with Lindsay's two technicians. And so I really wanted Benji, who's our civil engineer, to speak with them and learn about just things, because Benji has to do the design. He has to understand the land stuff. He's the civil engineer. He's our general contractor. And it was just neat to talk to him. Specifically, I was just showing you the last image you had there was the wider tractor. They have two ways of dispersing seed on site. They have this piece of hardware, which has a couple of functions, but it literally rolls along the ground and distributes 16 pounds of finely chosen seed per acre. And that's a lot less than most people expect. I guess grass seed is about 600 pounds per acre, I learned. And so that's when you're using pollinators, you use much less and you finally put it. And that piece of hardware like cuts the dirt, puts the seed in, folds it back together and rolls over it. And so it was neat to learn about the process, the types of soils we have to deal with. We saw some of their product, and we got to see it in land that's like our land. Different regions have different soils, and just that it was just good to see the product being applied. And especially important for Benji to see it, because now we're speccing it in multiple projects, 5, 6, 7 projects. We have Ernst's pollinator service as a byline in our cost. So it's got to learn it, got to do it.
Yeah, I think pollinator friendly solar is so important for the industry and for the country. It is, it's so much easier for locals to get behind these projects when they know that it's going to be good for the environment. It's going to be easy on the eyes. It's for whatever reason, it is easier on the eyes when you're looking at grasses and forbs, especially if some of the forbs are flowering, right? And you can see birds and butterflies and bees. It's it just it stimulates our brain. We go, wow, this is life, as opposed to just turf grass, which is not the end of the world. There's going to be plenty of that out there. The thing that I really love, though, about this, John, is that the maintenance costs, the overall long-term costs of pollinator-friendly solar, in our experience, having run the numbers on quite a few projects now, it's lower total cost of ownership.
Correct.
And you can't argue with that. That means lower cost of energy. And that's what this is all about at the end of the day. Even though you and I care deeply about the energy transition, there are plenty of solar investors who probably don't.
Nope.
And this is just a financial tool for them.
Yeah.
So,
there's two, you mentioned color and ways of doing things. And, one of the items that Lindsay brought up was that, these are bifacial solar panels. And one of the things that they want is reflectivity, so that they pick up that albedo, they pick up those extra photons and throw out some extra electrons. And Lindsay said that for one of the projects that they worked, the group specified a white flower that had a high albedo. And Lindsay had to explicitly give them the seasonality of the flower so that they could model it. And so I'm really interested in how you model flower seasonality and blooming and stuff like that. And I actually wrote Nextracker a tweet saying, hey, does your True Capture software, because their software is machine learning, and so it optimizes during its lifetime, does your True Capture account for flower seasonality? And I just thought that was kind of neat. I've never had to consider that in my models yet. I've never really done a bifacial system, truly. So I'm not there yet. But that sounds like a variable that would stress me just a tiny little bit. How are the flowers going to bloom? It's kind of funny.
I've been surprised how many sites, both sites that we're developing and sites that others are building, are bifacial now here in Illinois. I would say at least half the sites, these ground mount community solar projects, are bifacial projects. I'm thrilled. I mean, I love technology, and it is greater energy density with a bifacial module, right? Which means we have to develop less land for the same amount of energy at the end of the day, and that's a good.
There's also another factor right now. Right now, there's no import tariff on bifacial panels. And a smart person who I was chatting with from the Midwest suggested to me that it's about a 2.5 cent per watt difference for the modules, this tariff difference. So it brings bifacials either right in line with standard panels or just below them in terms of cost. And so I was like, well, okay. But he gave me that 2.5 cent number, and I'm like, good to hear. And he worked it out. A PhD type guy who's real smart says, yeah, here's what the real number difference is when we buy at wholesale, 2.5 cents for them. So if you get
Meaning,
real,
meaning that the panel is actually a little more expensive on a per watt DC, but the the actual cost once you calculate the energy return is just
no, no, no.
slightly higher, or
No, in general, the panel is bifacial panels are a little more expensive because they haven't scaled as much as standard panels have. However, because of the import tariff that the United States has on solar panels, the import tariff is worth about 2.5 cents a watt. And so right now, bifacial panels are about 2.5 cents a watt cheaper than they would be
ah,
naturally because there is no import tariff on a bifacial panel. There's import tariffs on all the other imported panels. So
yeah,
that
they're
import,
bickering. They're bickering still about this. I think that's
correct.
an unfolding story. Um,
It's still staying with no import tariff, but the
yeah,
current political administration in the U.S. suggested that they were going to pull back on it. Again, a judge said no, you can't pull back on it for this reason, and so it's still in place. One last pollinator thing before, so we can move on and do other stuff. There's a new seed mix out, and I just want to make sure everybody knows this. And I know it's funny, but the American Solar Sheep Grazing Society, something like that. If you type in all those words, you'll find it. They might be in the wrong order, uh, but they're the American Solar Sheep Grazing Society. They worked with Ernst and they came up with a seed mix called Fuzz and Buzz. And so you have the Buzz mix, which is pollinator friendly. Hey, there you go. American Solar Grazing Association, Fuzz and Buzz. Oh, there it is. Um, so they came up with this new mix that is specifically to make pollinator friendly and sheep friendly because sheep want to eat certain things and bugs want to eat certain things or pollinate certain things. And so they took a while. And I've been hearing about this for a year and a half. They were working with universities and just digging through stuff. And so now you can not only have sheep friendly to do the grazing, you can have pollinator friendly to tap into a lot of the regulations that are now required. Like the pollinator friendly is becoming worth money. And so this new seed mix applies to certain regions. And of course, every site is a little bit unique because of local conditions, soil acidity, X, Y, and Z. But Fuzz and Buzz. So now there's a new mix that's out, and they were very happy to launch it. And you can see the price there. I didn't realize it was $6.64 a pound. I had never been to that site, so maybe I should just buy some and throw it in my backyard to support the cause.
yep. The if you're in a state that does not have a pollinator checklist, you want to work on that. That is one of the fundamentals of this pollinator friendly world, because there needs to be some real legit science with entomologists and other scientists at the table, designing mixes that are going to be low growing, right? Because you don't want to have to mow it too much, and you don't want it to shade your solar array, and you don't want to have to jack up the array. So that is that's not simple, because grasses will, especially grasses, will quickly grow above 3 feet, which is kind of the standard. Um, Sometimes you see panels a little lower. I don't know. Here in Illinois, we try to get 36 inches above ground, but
Yeah, they like 36 inches for the panels so that with just the way you plant things. So that's actually a really important height for the pollinator folk so that they can manage it and grow key resources in key areas. So do attempt to communicate with your pollinator people earlier in the process so that you can kind of learn better some of the technical things you have to do, because taller solar panels are more expensive, or racking is more expensive. It's extra steel. So you got to run those numbers and understand, if it's required, you got to get over it. That's life. At least if you want the product to perform well. So,
yep.
pollinators are cool.
Gotta love the birds, bees, and butterflies. So here's a story about a company in Austin, Texas that you were kind enough to bring to our attention. Leading edge equipment technologies secure more funding for solar silicon wafer manufacturing. Honestly, John, I thought wafer manufacturing was negligible in the US, so I'm thrilled to see somebody going after it. What's the deal here?
So, well, it is negligible in the U.S. You're very right about that. We may have some cells. We spoke about Violet, who's coming online with something out in Washington State, picking up the old REC silicon facilities. So
Yes,
there's
indeed.
that. But this leading edge group, they got this new technique. It's called the floating silicon method, which is different from making those ingots that we're all used to seeing. You see that big long round thing. It's a shiny gray, silvery black, and that's like an ingot of polysilicon or multi-silicon or monosilicon, and that's what you then cut up. You literally use a saw, and these days they use a diamond saw. And I don't think it's real diamonds, but maybe they have actual diamonds on the edge of the leading edge, and they're cutting this stuff. And there you go. That's an ingot. So they cut it, and they use like this diamond saw to cut them. And during that process, it takes a lot of energy to make these ingots. You have to melt it. A big chunk of the electricity usage that goes into making solar panels is done in the ingot manufacturing process. And so there have been many groups who've attempted to change this technique for manufacturing. There's one called 1366. There's others I've read about. And there's vapor deposition. So there's ways of doing things. These guys are pushing something called floating silicon, where they will spray down silicon in layers, and they say perfectly put down a ribbon of silicon instead of putting out, and then you just cut that one slice, and that's your cell. So you make your ribbon, your cell, as wide as your solar cell, and you just go dunk. And so you can just print out silicon and you spray it, I guess, somehow. And their pitch is that it's going to lower wafer cost by half, and wafers are, $10 out of that solar module price, 10, $12. It's going to increase efficiency. They noted something about oxygen getting into it, and it causes inefficiency because of the way you manufacture. So if you can get the oxygen out, it makes the panel better. And they say it reduces emissions by 50%. And that's pretty solid. Already solar panels pay back their emission level after 2 to 3 years versus dirty electricity. But if you can cut that in half, that's even better. So it's just a new way of hypothetically making cells. They want to make the machine that just gets dropped straight into the factory. So now the factory will no longer buy these big ingots and have to cut them and buy wafers from somewhere else. They're going to make their own wafers direct from polysilicon, maybe. I don't know the input material yet. Maybe it's a liquefied silicon, but it's just a drop in a machine into the existing infrastructure. And I always love that concept because there's tens of billions of dollars of solar cell machines, and this might be a new one. So it's just cool. It's a new cell technique. It's got a lot of uphill fight to win, and it's probably going to fail, but it might not. And so that's why it's neat to talk about.
Yeah, I mean, just look like we have crystalline PV and we have thin film. Those are two commercially viable forms of PV. Um, and we have a true blue American thin film maker in Ohio that makes gobs and gobs of utility sized solar panels called First Solar. And so I think there's lots of runway for new and better technologies for making silicon for solar panels.
Somebody's going to do it differently. This technique is called kerfless, Kerf less. There will be a kerfless product, in my opinion, out there in the world eventually, and it'll drop 20% off the price of our panels.
How far do you think we are away from seeing some commercial product?
Oh, well, from this company, probably years, 2, 3, 4 years, maybe, who knows? We're going to get some sort of pictures and videos by the end of the year, but anybody that's getting funding at this stage is 2, 3, 4 years out. 1366 seemed to be closer, but they started moving overseas. I don't know. I really don't know. It could be cheap enough to do the standard ingots for so long that they just hold on out for another 20 years just because they keep advancing slowly. But who knows? I mean, technically, who cares about the electricity usage if you're fully powered by renewables and we happen to have lots of it? There's a point where you can stop saying efficiency matters. If every electricity is clean on the planet, yeah, you want to use less, you want to be efficient, but who cares if it's cheap and it's clean? If you got tons of electricity, use it. See what happens. Make it however you want.
Cool. Well, here we have a story at the other end of the solar life cycle.
Yeah.
Gentleman in California who is decommissioning solar projects and theoretically responsibly repurposing the solar equipment. What do you think about this? It's no accident, I would say, that he's in California. We see Cesar Barbarossa here. Do you know Cesar?
No, I don't know him directly. He might be my favorite new LinkedIn account though, just because I get to see a piece of the work that's different than mine, and so I share him on Twitter all the time, and I always like his stuff on LinkedIn. So he's one of my new favorites. But yeah, I mean, it's funny though, because I've only been in the industry for like 12 years. So none of my systems are even hitting decommissioning age. Though I do see systems get decommissioned on buildings that have to get major roof upgrades. And, 10 to 15 year out solar system with new technology, efficiency, and in a high electricity demand building, it might make sense to just roll out some new panels or new stuff. So it's really interesting to watch that, and I love that they already have a plan in place to sell them to people. So they have places to push them, and I'm gonna, there's a gentleman who was introduced to me in Massachusetts, around the Boston area, who's already good at repurposing old gear for lower priced markets, less developed markets. So if you have old panels, there's a place for them to go. And it's not the dump. We don't need to even worry about recycling yet. There's not enough volume to recycle. We're not losing that many panels. Maybe in 20 years, there'll be a huge volume. But maybe in 20 years, half of that will go to markets that don't need the most efficiency, but want the product at 75% off, which means their electricity will be cheaper than ours. And I think that's a great idea. So every time he posts something, I'm always thinking, it's good to see that circular economy horizon right there. I like it.
Indeed, there's a huge opportunity, and it's good to see that ecosystem growing and getting off the ground. We also need to pursue zero waste manufacturing and make all this equipment easier to recycle. I think the solar panels themselves are one of the biggest challenges, but I'm not suggesting that's an easy thing, but it's a thing that we need to do. Let's move on. You've got a story on your blog, John, at commercialsolarguy.com/news, which I'm going to show you here in a second, about the Tesla Model Y and MPGE. What are you talking about?
I'm just making stuff up. I'll be honest with you. I just like that little term there. Uh,
Well, it
so
stands
so
for miles per
MBG, I didn't
gallon
make it up.
equivalent, right? MPGE or MPG electric.
Well, yeah, no, actually, it's equivalent emissions, and that's why I had to make it up because the motor people, the official adults of the room, have already got an MPGE value, and they're doing this equivalent to gas electric thing. But since I'm just writing one article, I'm allowed to do what I want, and so I just added parentheses around the E and a little asterisk for the sake of it. But it's really about the emissions that the car is giving out. And I wanted to point that out because I drove to New York, and while I was at a supercharger near Albany, I was just saying, what is my efficiency? Because New York, I happen to know, has very clean upstate electricity. I do projects there, and we compete with hydro. It's nice and cheap, and it's hydro, so it's clean. And so I just went online. I did a search. Oh, now you're to it. And I looked at those two maps, and I've known about this work that the Union of Concerned Scientists do. And every year they come out with an update, and they look at the electricity that we're generating on a regional basis across the U.S. And then they apply it to, and instead of saying, okay, a gas car puts out this. Well, here's the way it works. A gas car puts out about 20 pounds of CO2 per gallon burnt. An EV puts out emissions at the factory where the electricity is burnt and the grid that it's on. So it's what you plug into. So what they did is that they looked at an 88 mile per hour EV. That's on the previous one you were just looking at, the blue map. And they said, here's what an 88 mile per gallon EV would output in emissions compared to a gas car. So you're in, I'm in Massachusetts, and my car, a normal Model Y, would output comparably to a gas car, like it's 230 miles per gallon. So a gas car that gets 230 will output this much. That's what my car puts out in Massachusetts, in the New England ISO territory. In upstate New York, that number jumps to 272 miles per gallon emissions equivalent. And that means the electricity that's being pumped into upstate New York, it's like everybody in upstate New York should be driving an EV. And I can't think of any reason why they shouldn't, other than they cost a little more. And that's understandable. And maybe the technology is not out for all the vehicle types yet, but it's moving. And the electricity, your EV will be the cleanest vehicle for 1,000 miles around if you fill it up in New York State, upstate New York, and 272 mile per gallon equivalent from an emission standpoint. That is, that's technologies, that's advancement. That's the report from the scientists said that's 1/10 the output of a standard EV in terms of pollution.
I know
So
you've
1/10
explained
is,
this to me before, but I'm a little slow, John.
yeah.
So help me out here,
Okay.
man. What is the deal with this 306 in New York? But here I am in Illinois and I'm getting 74 MPG. Why such a delta?
So in New York, there's a huge amount of hydroelectricity that's upstate New York. Notice it's NY up, not NYCW. NY upstate has a huge amount of hydroelectricity and wind and a little bit of solar, but mostly hydro that's filling up its power grid, and it's clean. And so clean electricity outputs no emissions or relatively low. Whereas you're in Illinois, which is PJM territory. You're within your state, you have a lot of coal, or within the region, there's a lot of coal. So it's looking at the mix of your power
so
grid.
it's the source of electricity that's the kicker.
Yeah. And so this right here is the most efficient EV. This is the Tesla Model 3, who gets around 130-ish miles per gallon on the highway. And so it gets a 306, which is even better than your and my Model Y, which would get a 272 because super clean electricity. So you're still driving on a car that's getting, 65 miles per gallon equivalent. And you can also be strategic. Maybe you only charge at high noon, or maybe you plug it into a power plant, solar plant, or do something a little better with it. So and one key data point to add on, sorry, then we can move on. But the grid is getting cleaner. And Tim, you are literally part of it. So every solar power plant we connect to the grid, we make that number go up just a little bit. And especially if you charge in the daytime. If you charge in the daytime at high noon, oh my gosh, you're probably 5% cleaner, 10% cleaner. In mass, I bet you're 25% cleaner because 10% of the overall electricity is solar. That means at high noon, maybe double that amount is solar, triple that amount, because that's when the solar is being produced. So maybe I should just only be charging my car from 11 to 1 in order to up my junk talking game for my clean car. So
Yeah, it's a good reminder for our listeners that look, getting into an EV is a huge step in the right direction, but we also have to clean the grid. So we can't stop there. We have to get the grid powered by wind, solar, and eventually batteries. And that's coming. And we've talked about those projects. And we're going to talk about a story that's related, which is battery technology. I'll just jump right into that. Tesla announced on Battery Day this thing called the 4680 battery cell. I call it the mini beer can cell. And 80 stands for the height and 46 stands for the diameter. Is that right? In millimeters?
Yeah, I think yes, in millimeters, definitely millimeters.
Yeah. So this is, it's so interesting that Tesla is able to do an analysis, do some R&D, and decide that no, those little, AAA size lithium ion cells is not the most efficient way to do lithium ion batteries. You should make a much bigger battery cell. So what's your take on this?
Well, the already there's been research suggesting that the current batteries that are in cars can reach 500,000 miles before they hit 80% of their original capacity. And that's what we're driving now. And you know what we're driving might be a little bit higher because that's year-old research of 2 and 3 year old cars. And so we're driving the newest, latest, greatest, etc. And now we have newer research that says cars that are getting driven slower, 10,000 miles a year, not like, the 30,000 miles a year that I'm scaling toward right now. I'm at 1 month of having the car and I'm almost 3,000 miles. So, that's a sales guy for you. But a 2 million mile battery, if you drove it 10,000 miles a year, that's 200 years. That means your battery, what the heck? I mean, you have a 200-year battery. You can give that battery to your kids. Your kids could give it to their kids. Their kids could give it to someone else. Like 4 long back-to-back generation uses. And, a 2 million mile battery means a lot of these assumptions we have in our pricing models about, long-term energy storage viability and saying, oh, we're going to have to replace stuff at 10 years. Well, that's going to fall away. We're going to have houses with batteries as the infrastructure, and we're going to learn to run them properly. And we're going to learn to have batteries that will last 50 years. And, just like you got to redo your roof every 20 years, you're going to be like, oh, we got to redo the battery wall now. It's been a 50-year run and it's at 85% because we're going to use batteries as structural. We're going to put batteries straight into the wall. And
or maybe the foundation even.
I would be annoyed with that because then you have to dig to get to them. But maybe it'll work. Who the heck knows? They could go anywhere. I mean, if we have a 200-year battery, what the heck? I mean, I don't want to say how a house battery might run yet because I have no idea. I mean, we're still this is a research paper doing modeling. So it's not, there obviously has been no 200-year battery. And this is a dude in a lab with hitting stuff with a hammer and doing all that hard work. But yeah, I mean,
lithium, let's face it, lithium ion technology probably won't even be with us in 200 years if we're so lucky to survive that long into the future. I mean, truly, unfortunately, we are at a point in history where 200 years, we will be very lucky to get that far. As a industrialized civilization, we might
Yeah.
survive as a Stone Age civilization, but so I have no qualms about putting a battery in the foundation of a building, just like Elon is putting them in the foundation of the EVs now. They're building it structurally right into the platform of the new Model Ys coming out of Berlin in a year's time when that factory gets turned on.
Yep. That's
And just a quick aside, John, I was looking at the size of the real estate that Tesla has bought in Austin, Texas, and I don't know the square footage of the actual factory, but the square footage of the real estate is 12x what they have in California. So the factory that they're or the potential for the factory they're building in Austin is just humongous. And everybody likes to poo-poo Tesla. Well, they've shot through the roof. They're one and done. This is a has been. No way, man. They're just getting started. And even though their market cap is larger than the other three American automakers combined, they make way fewer cars, and they're going to be making millions of cars. Next year, we're looking at 1 million cars, and then probably doubling year over year for several years. So big things ahead for Tesla. But you think the beer can strategy is critical to this 2 million mile battery? I don't know enough to know.
Well, it was the battery that they tested, and the battery size might be that. It could be any of 50 different innovations that are inside of that unit that they're testing and learning about and getting better with, because they're just improving stuff all these generations. That new battery has the tabless design. It's they're building it differently. They're using slightly different product inside chemistry. So
Yeah.
deep down, I didn't actually read the deep paper. I was just so hyped about that number, 10,000 miles, 2 million year or 200 years. It's
Yeah.
just like, okay, this is goofy, but it's cool. It's just a thing to think about. I mean, I was already like psyched about the 1 million mile battery, and I'm like, okay, that's a 10-year car, but I had never done the math on it. And I'm like, holy crap, that's a that's a lot of mileage. So I really just shared it because I just wanted to say 200-year battery, because that just sounds neat.
Well, we've got more Tesla content coming up, so stick around. But before we do that, we're going to take a look at a real live solar project of yours truly, John Weaver. What's going on, John, here? I love this this conduit shot.
Yeah, over the last week and a half, 2 weeks, I've been super busy. I just visiting sites. I had different places in different spots, and so this is a project in Pawtucket, Rhode Island. It's a rooftop atop the Hope Artist Village, and we have a 592 kW, and we're kind of near the end of it. The panels are installed, racking's done, everything on the roof is done, DC wiring is done, inverters are in place, and we're now doing the final AC electric connections. And I had to go visit the site and just kind of go through stuff. And so I'm walking around inspecting stuff, taking cool pictures. And I just love the look of all the final electrical work, because here's where you get the big wires, you get the big gear. I love the big switches, the fuses, all the metal. So I was just doing my fun little inspections, walking around on the roof. Finished aluminum is always just machined aluminum, I think, is great, just because it looks cool. And this is a tough project. It took me 4+ years to complete the development of it. We started talking with the customer in the fall of 2015, and for various reasons. And it's also a really old structure. I mean, that's the basement where we're at. This is a structure like late 1800s.
That looks like a dungeon.
Yeah, sorta.
But yeah, that's the nature of the beast, right? You got some really old buildings there in the Northeast.
So this is it's a great project to see completing. We're about to start pulling some wire here. That round thing you see there in those two bars that it's connected to, that's so you can see those two open tubes on the far left. That's going to be going down those tubes that you just saw, the conduit going up the side of the wall. And on the right lower side, that's all the wiring on the AC side coming from the inverters. So it's coming in on the lower right. There's 5 tubes. You can just sort of make it out. And this is the wire pulling machine. So that guy's about to get turned on and tug some cable through there. And that's what we did. That's what we did that morning. And that's the 5 inverter sets we have coming down the floor. Or on the roof actually, but connecting into that and that unit you saw there, that's the PV load center. And so that's all the AC coming in, getting combined into some tighter stuff, and then going down under the ground to the dungeon. And so I really am just happy that we're done with that project. It's been something I've been working on for a long time, doing really well for the customer, we think. And that was just one of the 3 projects I visited this past week and a half that I took some pictures of and shared on Twitter.
Nothing better than seeing your projects come out of the ground, get built, get turned on. That's my favorite part of the business. All right. So should we talk Megapack or what?
I like the Megapack stuff. I'm dealing with it in a real project out in California. It's what's being built at this. So the Ukaipa Valley Water District, if you're really interested, you can log into their website and hear them talk about these projects I'm working on. There's a presentation going on tonight where they'll be presenting 3 projects from 3 very talented development teams. And oh man, there's a picture of the Megapack and that weird truck, that Mr. Jack thing on the left, which I just thought was sweet.
Yeah.
So that's at Moss Landing in California. That's an
Yep.
old gas plant that's being decommissioned, and they're putting in a huge volume of batteries from different groups that are doing different functions. And so, Megapack's coming out. It's Tesla's utility scale energy storage product. I think it starts around 3 to 4 megawatt hours of capacity, and 1 megawatt AC is like the minimum size. 1 meg 4-hour battery. I think I've not really gone into specs and design yet myself. So it's their thing, and they were talking about on their quarterly call. I put on our document here that you can see. They said Megapack demand is sold out through 2021. And they're ramping production through 2023 to get more capacity. And they're selling out that capacity through 2023. This is all, what is this? Where'd you find this, sir?
This is the Moss Landing site from a drone. I had found this earlier in the week.
Wow. Look at that. Look
Under
how
construction.
cool that is. You guys
Yeah.
share that with me. I'm totally writing that article. Look at all those Megapacks down there. You can see them on the ground there, starting to get put out.
Yep.
Those white boxes. There's more coming up here on the right. Oh man, what a cool thing you found there. Sweet. You can see them clearing out the land. The Megapack. So you have many Megapacks, which are the main battery capacities, and then you'll have somewhere near the edges the main inverter hardware. You can see the little yellow guy, that yellow truck over on the left side that carries them. That's kind of cool. Really neat. There's the construction site, and there's multiple groups here. So, there could be multiple projects that are being built, but, Tesla has something, a group named Vestra has something. There's 4 separate groups who are installing batteries at Moss Landing as part of the Pacific Gas and Electric project going on there. And
this is truly the future of the grid, John, what we're looking at right here, right? They're taking an existing power plant and basically repowering it with batteries.
Mm-hmm.
There's going to be a lot of this because it just makes so much sense economically, right? You've got that. Look at that substation. That substation is bigger than my neighborhood.
I think it's like 6 gigawatts or 4. It's in the 4.7. I'm just, memories coming up from reading all these dang documents on this site. I've read so many different documents on this site that are filed with the bureaucrats, the state, as going through these projects. And I think it's like 4.7 to 5.5 gigawatts of capacity that can come through the power lines here. And that's why they're trying to get as much energy storage there, because this is a very electricity intense region that surrounds it. But you can't build a giant solar power plant there. You can't build a giant wind farm there. So you have to import the electricity for as much as you can at 4.7 gigawatts at a time, fill up these batteries, and then output it at the strategic moment later on. And that's, you can see what they're doing. Man, look at those images. That's awesome. Look at this drone fly.
Yeah, I'll send this to you. And I'll mention it, what channel it's on. But yeah, this this is a beautiful thing. But that story in Electrek
Mm-hmm.
is talking about it's relevant to the evolution that's happening with the battery cells, right?
Mm-hmm.
We're getting bigger and bigger kWh capacity batteries, the Megapack today, and and at face value, I think it's what, is it a megawatt? And
The
in
megawatt power
yeah,
and 4
megawatt
megawatt hours
power per
capacity.
container.
Ooh, maybe not per container, per chunk of containers. So there's with the mega pack is actually multiple shipping containers.
Okay.
So there's hardware and then you roll them out in different groups. So it could be like one shipping container holds all the capacity, 4 megawatt hours worth, and then there's a separate shipping container with a bunch of control systems. And the Megapack system is optimized to scale quickly and efficiently. That's really what it is. It's a truly utility scale system design. It's not just a battery cell. It's not a battery pack. It's not a single vertical combination of these batteries like you'd find. It's not even a single shipping container. It's many shipping containers is the vision here. So it's about rolling out a utility scale product. And it might be among the first that are like specifically designed that way. I'm sure some of these large groups have looked at it that way, but this is early in terms of we're still early in terms of utility scale energy storage design and optimization. I mean, I saw Fluence built a building that was just a whole battery, and so did S Power. The biggest battery in the world is inside of a building right now, built by S Power in San Diego, and I think they can triple, maybe quadruple the size of it. It's a 250 megawatt battery, 250 megawatt power, so it's a 1-to-1 ratio, and it's a building. It's inside a building. So how the techniques for building this stuff are evolving. And in that building, the batteries are stacked on top of each other. So your energy storage density is doubled, tripled, quadrupled on an acreage, on a square footage standpoint. Megapacks, I guarantee you they're going to go up into the up dimension. I just assume. I mean, why not? Then you can have more and more and more. I bet you there's a building somewhere and within the Tesla libraries just full of batteries, just like a data center. They look just like data centers on the inside. And, they're moving electrons and wires. They got packs that look just like, computers that you pull out of that rack. And it's pretty neat. I love the way this is developing. I love that they're sold out. I love that I'm working on a project that's going to have mega packs because now I'm starting to see, real spec pages and hear smart people who work with it talking about it. And Ukaipa Valley Water District, one of the bidders is pushing a mega pack, and whoever installs it, they're all awesome groups, but it's just neat to watch mega pack evolving and new product. I'm going to sell them one day. Looking forward to it.
Yeah, I'm working on a Megapack project in Joliet. It's probably going to be 2022 before it goes to construction. We'll see. But the thrust of that article is seemingly about the price per kWh, though, that stationary storage gives versus mobile storage, and I couldn't discern what they were trying to get at there, though. I know that Tesla uses different chemistry in their premium mobile storage compared to the stationary storage, and they're increasingly going to lean on for example, lithium iron phosphate for stationary storage, which is a lower cost than the lithium nickel hydride. What do they call the nickel battery that is used in the high performance vehicles? That's about all I know. Nickel is for premium applications and iron is for less premium.
They're evolving. We'll see.
What other stories are we? Oh, we're at the end of our list. So, John, I want to remind our listeners that they can find all of our content at cesnrg.com/videos. Both the Solar Podcast and the Clean Power Hour, all of the episodes are right there. So please go there, subscribe, give us a thumbs up, and most importantly, share it with your friends, because that sharing is really what grows the channel. John, how can our listeners and viewers find you?
Well, you can type into Google commercial solar guy. I am all over that machine. And you can go to my website, commercialsolarguy.com. You can go to LinkedIn, type in commercial solar guy. You can find my name, of course, John Fitzgerald Weaver. I'm actually the only John Fitzgerald Weaver that might be alive right now who comes up in Google searches. There have been a few others I've seen in history. A couple of them have died. So hopefully if I ever meet another John Fitzgerald Weaver, I'm bigger than him and I can take him out. So, either one of those, commercial solar guy, solar commercial consultant. I also come up pretty high in Google searches. So I do a decent amount of large scale consulting when we can't build it ourselves or it's too far away, like we're doing for this California project. We're really the customer's engineer, and we're doing our best to parse these bids, these very complex bids for multiple microgrid systems to keep a water district up. And so that's part of the work we do. We're a GC, so we'll build it for you, or we'll just talk about it with you. Whichever piece you happen to need from us, we're there for you. commercialsolarguy.com.
And I'm Tim Montague, your co-host. Thank you so much for listening. We'll see you next week. Thanks, everybody.